4.3, the augmented matrix. When we have a system of equations such as the one that we have in the example here, the first one being x minus 2y plus 3z, we can, even for the ones with no coefficient out in front, we know that that coefficient is equal to 1. And when we are missing, in the second row here, when we're missing the y variable, we understand that that coefficient is actually equal to 0. And so we have a set of coefficients. We can work with that set of coefficients as a matrix. And the augmented matrix would be when we have everything that's on the right-hand side indicated as well, of the system of equations indicated as well. Okay, so let's take a look here. And what we're going to do is we're going to understand that everything in this first column here is an x coefficient. Everything in the second column is a y coefficient. Everything in the z column is a z coefficient. In each row corresponds to a separate equation in our system of equations. Oh, yes, and of course, the right-hand side of the equation is indicated by this bar and then those particular numbers. All right, so let's go through this and make sure we understand it. In the first equation here, in this first equation, the coefficient x is 1, minus 2, 3, and then of course we're going to have 12. 1, minus 2, 3, and then 12. That's our first equation. Okay, so it ends in the first row. Here we have 2x, and we've understood that the coefficient of y is 0, 4, so 2, 0, minus 4, and 8. 2, 0, minus 4, and 8. And the very last one, again, we have another 0 because the x is missing. 0, positive 3, positive 1, 7. 0, positive 3, positive 1, 7. And of course, we can go the other direction as well. We can, given the augmented matrix, we can write out the system of equations. Here's an example. Here's our augmented matrix, slightly different. And we're going to go ahead and we're going to write out the equation. Okay, so remember, this is the x column, y, and z. So for our first one, we're going to have 2x plus y minus 4z equals 12. 2x plus y minus 4z equals 12. And there we have our first equation. Our second is going to be 3x. There will be no y, or we'll just put y in, y times 0. Okay, plus 5 times z equals minus 1. 3x plus 0 times y plus 5z equals minus 1. And then later on, of course, we'll drop that. Okay, here, this one is interesting. Okay, so we're not going to have any coefficients out in front, but what we are going to do is we're going to use those coefficients to place a sign. So this is going to be x minus y plus z is equal to 2. X minus y plus z is equal to 2. And that's exactly what we see right here. All right. Let's go ahead and let's drop that y equals 0 because it just looks funny. And we have our matrix right there. Okay.